My project is an implementation of ZoomShop and a comparison with generative fill. The main motivation behind ZoomShop was to allow users to edit image composition such that they can achieve aesthetics that may not have been possible under a linear image formation process. The motivation behind a comparison with generative fill is that although I'm a computer vision graduate student who has some context behind how generative technology works, I'm a novice photographer and don't have a lot of experience with photo editing tools. Therefore, I wanted to explore the capabilities of generative fill and determine whether or not a tool that was developed before the giant boom of generative modeling, like ZoomShop, is still useful and whether the current state of the art in generative photo editing can match these effects. To briefly go over linear perspective, given a focal length, image half width, and half height, linear perspective maps 3D scene point to a 2D image coordinate as follows. The authors of ZoomShop proposed to replace this linear perspective mapping with the nonlinear function b of z, where lambda is the aspect ratio of the image. Now, to recreate linear perspective mapping, b of z can be set to this, but the real power is when we make b of z nonlinear with respect to depth, which allows for editing scale and foreshortening of images. The pre-processing steps for this algorithm are to first compute a depth map of the given image and to then convert it to a 3D point cloud. Once we have this 3D representation, the user can select depth ranges and edit vertices on the point cloud, which is then re-rendered into the image. Due to some rendering limitations that are discussed in the report, I first use an iterative relaxation scheme that solves Poisson's equations to fill in grid values, and then fill in the remaining pixels with content-aware fill as the original paper does. For comparison purposes, on the left is the input, the reported result from ZoomShop is in the middle, and my result is on the right. Upon close inspection, there are definitely artifacts in both the ZoomShop images and my implementation images. However, the overall desired edit is achieved, and the remaining artifacts are largely due to the quality of the predicted depth map, among other things. And here are some more results. This is the Palace of Versailles. And here's a gargoyle looking over Paris. Finally, to explore generative fill's capabilities, I conducted a small user study with family and friends who were all aware of what generative fill was, but had used Photoshop very minimally, if ever, except for one participant who was a seasoned user. To provide context and instructions on Photoshop's tools, the participants were instructed to view some tutorials on basic Photoshop operations, generative fill, and content-aware editing prior to the user study. At the user study, they were given time to familiarize themselves with the Photoshop UI, as well as the ZoomShop UI, which I will show a quick demo of here. It essentially allows users to select depth ranges directly from the image and set appropriate scale values manually. Once the participant felt comfortable enough with both UIs, I showed them an input image and an output image generated by ZoomShop, and then gave them 5 minutes with each tool to recreate the output. I then presented them with the following statements to rank on a 5-point Likert scale for both generative fill and ZoomShop. The main takeaways from this user study were that for editing scale and foreshortening of complex scenes, the ZoomShop interface and algorithm is much more user-friendly, with 70% of users feeling comfortable that with more time, they could recreate the reference output, while only 10% of participants felt even neutral about recreating the reference output with generative fill. For this specific objective, it is extremely difficult to preserve the content of the original scene using purely generative fill. And for complex scenes, it's not feasible for a novice user to use content-aware editing tools to recreate the effects that ZoomShop enables. The main limitations I found during implementation, and that we can see in the results, is that the quality of the generated result is quite dependent on the quality of the predicted depth map. Therefore, it is important to either mitigate dependence on this intermediate depth map prediction, or to develop methods for cleaning up these depth maps and generating more geometrically consistent results. For future work, I would like to implement the translation operation that ZoomShop implements and also build a more complete ZoomShop UI. Thank you.